So good morning to all. Today we are going to cover a very important topic of microprocessor and microcontroller syllabus, that is addressing modes of 8086 microprocessor. As we have already known that 8086 is a 16-bit microprocessor, means its data bus is of 16-bit and address bus is of 20-bit. But as we all know that memory is byte addressable, that is, each location of memory consists of 8-bit data. And here in 8086 we have 20-bit address, which is not a byte compatible number. So to utilize this address bus and address the complete memory space of 2 to the power 20, that is 1 MB memory, the memory is divided into various segments. That is called as memory segmentation. Out of these various segments, for a single program, 4 segments are accessed at a time, called as code segment, data segment, stack segment and extra segment. Code segment, and each of these segments is of 64K. So we can say that the whole memory of 8086 is divided into various segments. And these segments will contain the data. So the overall memory is divided into various segments and each segment size is 64K. That is, the register used to specify the starting address of each segment contains 16-bit size, since 2 to the power 16 is equal to 64. So these segment registers, code segment, data segment, stack segment and extra segment, points to the starting address of each segment register. That is, for this code segment, the starting address is in code segment register. For data segment, the starting address is in data segment register. Similarly, for extra segment, starting address is in extra segment register, and for stack segment, the starting address will be in stack segment. Now, since its starting address is specified in segment register, which is of 16-bit, but within this segment, the offset address is specified in index or pointer registers. So with code segment, instruction pointer is used. With data segment, BX, base register or base pointer is used. With stack segment, SS, stack pointer and base pointer are used. And with extra segment, destination and index register, and with data segment, source index registers are used. So these are the various pointer and index registers which are used to point the address within each segment. For example, if we talk about the code segment and we have to go within this code segment at a particular address, then this within address is specified in instruction pointer, starting address is specified in instruction pointer, and the complete 20-bit physical address is specified using segment register, which is shifted left by 4 digits and 4 zeros are appended. Then this value is added with offset or effective address, which is specified in index or pointer registers, and this will give the complete physical address of 20-bit. So we are discussing this whole lot because this calculation of converting effective address to physical address will give different addressing modes for memory addressing. So this offset is also called as effective address, and it may contain one or several registers. So the effective address is specified in either base registers or index register, or can be directly specified by 8 or 16-bit displacement. Base registers can be BX or BP. Index register will be SI and DI, that is source index and destination index. And there can be 8 or 16-bit displacement. So this is the overall calculation, and based on this calculation, various memory addressing modes are specified. So now we will move towards addressing modes. So what are addressing modes? Each instruction consists of two parts, opcode and operand. The way a microprocessor fetches operand from memory gives various addressing modes. So in case of 8086, there are 12 addressing modes. We have already discussed these two and this one in 8085, that is register, immediate and implied addressing mode. So group 1 consists of register and immediate data addressing modes, where the operand is specified either in register or immediate data. Group 2 consists of various memory addressing modes. As we have seen that the effective address can be base register, index register or date placement. So using the combination of one or more, the various addressing modes are direct addressing mode, where only displacement is specified. Register indirect addressing mode, where either base or index register is specified. Base addressing mode, which consists of only base address. Index addressing mode, which consists of only index addressing. Base index addressing, which consists of base plus index. And string addressing mode will consist of segment plus source index and destination index registers. Next is direct and indirect IO port addressing. In 8086, since data bus is of 16-bit, so the number of IOs can be, the accessed can be 2 to the power 8 in case of direct IO port addressing, and 2 to the power 16 in case of indirect IO port addressing using 16-bit register. Next is relative addressing, where the relative address is specified in instruction. And last is implied addressing. So now we will move towards the very first instruction, that is register addressing mode. As the name of instruction specifies, the operands are in register only. For example, move, the various registers in case of 8086 are AX, BX, CX and DX. Which are 16-bit. If we talk about 8-bit, it is AH, AL, BH, BL, CH, CL and DH, DL. So any of the these 8-bit or 4 16-bit registers can be used. The only one condition is that both the operands must be of same size. That is, move CL, DH. This instruction copies the content of DH to CL. But if we want to write move CL, DX, this is wrong instruction, because DX is of 16-bit whereas CL is of 8-bit. So the only condition is that both the operands must be of same size. So as we have seen, this is the general purpose registers. Then instruction pointer, various segment registers can also be used, and pointer and index registers. So instruction pointer, code segment, data segment, stack segment, extra segment, stack pointer, base pointer, destination index, source index and flag registers. Any of the registers can be used in register addressing mode instruction. Next is immediate addressing mode. Herein, the 8 or 16-bit data is immediately specified in the instruction. The value of this data can be copied to register or memory location as per instruction. For example, move DL, 08. So this instruction copies 08 to DL register. Here also both the operands must be of same size. Either both will be of 8-bit or both will be of 16-bit. Next is memory addressing mode. It is very important because as I have already explained you that the memory address consists of 20 address lines. However, the size of largest register is 16-bit. So we have to convert 16-bit to 20-bit to calculate 20-bit physical address. For this purpose, the whole memory is divided into various segments, and at a time 4 segments are used called as code, stack, data and extra segment. Each segment register has its specified offset or index registers, and we can write it in the form of like segment register CS :IP. This is the way we write segment offset pair. It means the physical address is CS with a 0 plus IP. This will give the complete 20-bit physical address. So basically the processor shift the segment register 4 places and append zeros and then add the offset value to get 20-bit physical address. For example, we have to calculate the 20-bit physical address using 89AB, that is segment, and F012, that is offset. So the value will be 89AB0 plus F012, which becomes 2CA 15 plus 9. As we have already seen the hexadecimal addition, 15 plus 9, 24 minus 16, that is 8 and 9. So this will be the physical address or the absolute address for this particular segment offset pair. So various addressing modes consist of the different combinations of base, index or displacement. So in case of direct addressing, the effective address is specified using displacement only. So the effective address is just a 8 or 16-bit displacement. And the by default segment register used here is data segment. Herein, the 16-bit number can be data or address. So if we use a square bracket, it means it is a offset value or address. And if will not use the square bracket, then it is a immediate data. So the square bracket around 134 denotes that these are the content of memory location. So in this case, the memory address will be data segment into 10 plus 13454. The value of address and address plus 1 will be copied to BX register. Or in the second instruction, DS into 10 plus 0400 value is copied to, content of this location is copied to BL register. So this is a word operation and the second example is of byte operation. So since the displacement is directly specified in the instruction, that's why it is called as direct addressing mode instruction. Next is register indirect. Herein, the effective address is specified in one of the registers, either in base register or in index register. Only one of the register is used. So the effective address can be BX, BP, SI or DI. The segment register by default is data segment for BX, SI and DI. Whereas for base pointer we use stack segment. So the effective address will be content of BX register. Physical address will be DS into 10 plus effective address. And the content of this memory location is copied to CX. That is address and address plus 1 location is copied to CL and CH respectively. Next is base addressing mode. In this case, base plus displacement is used to provide the effective address. So based addressing mode, here the effective address is specified in one of the base register plus 8 or 16-bit displacement. So the BX or BP holds the effective address in addition to displacement. If we are using BX, the data segment will be DS, segment register will be DS, and with BP, segment register will be SS. So for example, if we write BX plus 08, then the effective address is equal to BX value plus 0008. And physical address will be DS multiplied by hexadecimal value, or DS multiplied by 10 plus effective address. The content of this address and address plus 1 is copied to AL and AH respectively. Next is indexed addressing. Herein, one of the index register plus 8 or 16-bit displacement will give the effective address. So, index register plus displacement is used to provide the effective address. We can use either SI or DI, and segment register by default will be data segment. So let this will be the example SI plus 08 to H. So the complete physical address will be content of SI plus 00A2. This will be effective address plus segment into 10 will give the complete physical address. The content of this address plus 1 is copied to CL and CH respectively. Next is base index addressing. Herein, the effective address is all specified in base plus index plus 8 or 16-bit displacement. Segment register used is data segment, and the content of this address is copied to address and address plus 1. That is data segment into 10 plus BX plus SI plus 0A. This will be the physical address. The content of address and address plus 1 is copied to DL and DH respectively. Next is string addressing mode. In case of string addressing mode, as we all know that 8085, before starting about this instruction, we will discuss what we mean by string. In 8085, string is not, 8085 does not support string. String means a set of data. So when we talk about memory, it consists of an array of locations. And if we talk about a string, means a group of data starting from a particular location. Let the starting address is 20,000 and we are taking 10 bytes of data from this string. Then starting from 20,000, next 10 locations will be fetched. If the data, each data is of 16-bit, then starting from 20,000, since each data will take 2 locations, so 20 bytes will be fetched. So the string instruction means a string or set of data, and its effective address is specified in a source index and destination index register. So the effective address of source string is specified in SI register, and effective address of destination string is specified in DI register. With source register, segment register is data segment, and with destination register, destination index, the data segment is ES. So we can say that source address is data segment SI, and destination is extra segment and DI. So this will specify the starting address. In case of byte, only one location is required to fetch one data. In case of word, 2 locations starting from this address will fetch single data. Now, if we have to work with this string, we have to specify the next address. Whether the next address will be +1 or -1 will be given by direction flag. If direction flag is 0, then the next address will be +1. That is, SI plus 1 will be next SI and DI plus 1 will be next DI. And if direction flag is 1, next address will be auto decremented. That is SI minus 1 and DI minus 1. So if we take an example, let data segment is equal to 2000, extra segment is equal to 3000, source index is equal to 4000, destination index will be 5000. So we are taking just an example to show you how next address will be calculated. So first of all, what will be the starting address of source string? Hope everybody has clear. Data segment into 10 plus source index. So 2000 into 10, that is 20,000 plus 4,000, that is 24,000. This will be the starting address of source address string. What will be the starting address of destination string? Extra segment into 10 plus DI. So 3000 into 10, that is 30,000 plus DI, that is 35,000. If we are talking about byte string, then this location will give one data and this data will be copied to destination, only one location for each data. But if we take about word string, then 24,000 plus 1 will give single data, and similarly 35,000 plus 1 location will give a data. Now, this will be the starting address of source and destination. What will be the next address? It depends on direction flag. If direction flag is 0, this address will be automatically incremented. That is SI plus 1 and DI plus 1 for byte operation. SI plus 2 and DI plus 2 for word operation. Similarly, if direction flag is 1, this address will be auto decremented. That is SI minus 1 is equal to next SI and DI minus 1 will be next DI. So hope this calculation is clear to all of you, that how effective address will be converted to physical address. If for source string it is DS SI and for destination string it is ES DI. So the calculation of source memory is SI effective address, then physical address will be DS into 10 plus SI, and of destination string it is ES into 10 plus DI. So if we talk about move string byte, this instruction copies the value of source to destination. If direction flag is 0, next address will be auto incremented, whereas if direction flag is 1, next address will be auto decremented. Next is IO port addressing. In all the previous 8 addressing modes, we have discussed about fetching data from memory. Now we talk about IOs. As we all know that the data bus of 8086 is of 16-bit. That is, we can access up to 2 to the power 16 IOs using 8086. But in case of direct IO port addressing, we can specify only up to 2 to the power 8 IOs using 8-bit port address. So using direct port addressing, only 8-bit port address can be specified directly in the instruction, and hence up to 2 to the power 8 IOs can be accessed. For example, in AL, 09. So 09 will be the port address. The value specified in this address is copied to accumulator. So since the address is directly specified in instruction, it is called as direct IO port addressing mode. In case of indirect addressing mode, we can access 2 to the power 16 IOs using 16-bit address, which is using a 16-bit register called as DX. So herein the port address is specified in DX register, and this register is used to address memory indirectly. For example, out AX comma square bracket DX means DX consists of memory address. So the value of AX is copied to memory address whose value is specified in DX register. So let AX is equal to 2000 and DX is equal to 3000. So 3000 is the memory address, IO address. The value of AX is copied to this address and address plus 1 location. So this value is of AX is copied to, that is first 20 and then 00. So the value of AX is copied to DX register. Since the memory is addressed indirectly using a 16-bit register, which is by default DX, so it is called as indirect IO port addressing mode. Next is relative addressing mode. In this addressing mode, the effective address is specified relative to the instruction pointer. In case this addressing mode, the effective address is specified using instruction pointer. That is, basically it points to the next opcode. Instruction pointer is by default used with code segment register. So the physical address will be given by CS into 10 plus IP. Let we talk about JZ0A. So the effective address is 0A. If we write in 16-bit, it is 000A. So if 0 flag is 1, then the effective address will be CS into 10 plus 000A. And if 0 flag is 1, then the program control jump to the calculated address. Otherwise, if 0 flag 0, then the next instruction will be fetched. So the relative address of instruction is specified using code segment and IP registers. Basically, it specifies the next address wherein the program will jump. Last is implied addressing mode. We have already discussed this mode in 8085 also. In this instruction, no operands are mentioned specifically. So the instruction which consists of opcode only, and the opcode will specify on which data the operation will be performed. Then it is called as implied mode. For example, CLC, that is clear carry flag, STC, set carry flag, halt will specify end of program, and so on. So the overall addressing modes of 8086 are of 12 types, and we have discussed in detail. Everything is clear to all of you.